extension of type 1 and type 2, type 3. If I multiply A5 into B5, if both A and B are even, what are the last two digits? 25. These where A and B both are even. If both A and B are odd, what will be the last two digits? 25. Because we already discussed odd 5 into odd 5 or even 5 into even 5, last two digits will be 25. If one is even, another is odd. If one is even, another is odd, last two digits will be 75. That means if A is even, B is odd, or if A is odd, B is even, last two digits will be 75. This is something which we discussed in type 2. Now, let us discuss the number before this 25 or 75. The number before is given by the logic A into B plus A plus B by 2. In this A plus B by 2, if you get any decimals, please ignore the decimals. If you get any decimals, ignore the decimals. For example, 3.1 is 3. 3.9 is also 3. So let us take 2-3 examples to understand. 45 into 65. Step number 1. 4 is even, 6 is even. Even 5 into even 5. What are the last two digits? 25. A is 4, B is 6. A into B plus A plus B by 2. 24 plus 5. What will be the answer? 2925. Next example. 35 into 95. Odd 5 into odd 5. What are the last two digits? 25. 3 9s are 27. Plus A plus B by 2. 12 by 2. 6. 33, 25. Third one. 25 into 75. 2 is an even number, 7 is an odd number. Even 5 into odd 5. What are the last two digits? 75. A into B, 14. A plus B by 2, 9 by 2, 4.5. Ignore the decimals. If I ignore the decimals, what will be the answer? 1875. This is the case where A and B both are even. This is the case where A and B both are odd. This is the case where one is even and another is odd. It is also used for 3-digit number, 4-digit numbers. 125 into 145. This is even, this is even. Even 5 into even 5. 25. 12 into 14. 168. 12 plus 14 by 2. 26 by 2. 26 by 2 is 13. 168 plus 13. 18125. 18125. I hope it is clear. Now let me explain why we got plus 1. A5 into A5. A is even. Even 5 into even 5. Last two digits is 25. A is odd. Odd 5 into odd 5. Last two digits 25. The number before is given by the logic. A into B. A square plus A plus B by 2. 2A by 2A. A into A plus 1 ending with 25. I hope it is very clear why we got plus 1 in our type 1. So in squares of numbers ending with 5, we discussed 3 important logics. First logic, when the leftmost digit is same and sum of the remaining digits is 10 power k, type 1 is used. Type 2 is used to find out the last two digits of a number if a number is ending with 5. Logic, even 5 into even 5, odd 5 into odd 5, even 5 into odd 5. Even 5 into even 5 or odd 5 into odd 5, last two digits will be 25, else it is 75. Type 3, when you multiply any two numbers ending with 5, this is the logic. Last two digits are depending upon the nature of A and B. Now let us discuss how to find the cube of a number. In this module, I will discuss 3 important concepts. How to find the cube of a number. Type 1. To find the square of a number, we used A plus B whole square, which stands for A square plus 2AB plus B square. Same analogy here. To find the cube of a number, I will use A plus B whole cube, which stands for A cube plus 3A square B plus 3AB square plus B cube. Let us see 3 to 4 examples. 24 whole cube. A is 2, B is 4. So this will be A cube, 3A square B. Next will be 3AB square. Next will be B cube. 2 cube is 8. 4 4s are 16, 3s are 48. 3 2s are 6, 6 16s are 96. 4 cube is 64. Write down the unit digit. It is as equivalent to A plus B whole square. Whatever the ways in which we solve A plus B whole square, only the notation is different. The remaining everything else is same. 64, write down 4, 6 carried. 96 plus 6, 102. What is the unit digit in 102? 2. 10 carried. What is 48 plus 10? 58. Write down the unit digit 8. 5 carried. What is 8 plus 5? 13. One more example. 41 whole cube we need to solve. So this will be A cube, 3A square B, 3AB square and B cube. 4 cube is 64. 16 3s are 48. 3 4s are 12. 1 cube is 1. Write down the unit digit 1. Write down the unit digit 2. 1 carried. What is 48 plus 1? 49. 9. 4 carried. 64 plus 4? 68. Answer is 68921. Having understood these two problems, please practice 32 whole cube. If you use the same approach, 32 whole cube will give you the answer 32768. 32768. Similarly, if you solve 15 whole cube, you will get the answer 3375. 3375. This is a type 1, how to find the cube of a number. But unfortunately, if I use this type onto 98 whole cube, that will become A cube, 3A square B, 3AB square and B cube, which is cumbersome by nature. So, to find the cube of a number nearer to 10 power k, this logic is not the best logic. So, how to solve this kind of problems? Let us see it in type 2. Type 2. Let us see how to find the cube of a number. How to find the cube of a number nearer to 10 power k. How to find the cube of a number. How to find the cube of a number nearer to 10 power k. Now let us discuss how to find the cube of a number nearer to 10 power k. This is a level 3 concept. Please listen to this concept carefully. First we will write the notation b plus x whole cube equivalent to b plus 3x slash 3x square slash x cube. b is of the form 10 power k. Last two places should have k digits. Last two places should have k digits. Suppose first example 104 whole cube. This is nothing but 100 plus 4 whole cube. b is 100, x is 4. Substitute. So this will become b plus 3x, 3x square. Next is x cube. So this will become 112, 16 3s are 48, 4 cube is 64. 100 is a 10 square. Last two places should have 2 digits. 64 is a 2 digit format, 48 is a 2 digit format. Answer will be 1124864. Let us see one more problem. 1002 whole cube. 1002 whole cube. 1002 whole cube. 1002 whole cube is 1000 plus 2 whole cube. So this will become b plus 3x. Next is 3x square. Next is x cube. So this will become 1006. This is 12. This is 8. 1000 is a 10 cube. Last two places should have a 3 digit format. 8 in a 3 digit format 008. 12 in a 3 digit format 012. And this will be 1006. Answer is 1006 012 008. Let us see one more problem. 96 whole cube. 96 whole cube. 96 whole cube. Till now we solved two problems where x is positive. Now let us take x negative. 96 whole cube is 100 minus 4 power 3. So this will be b plus 3x square and x cube. So this will become 100 minus 12, 88, 16 3s are 48, it is minus 64. When you cube a positive number, you will not get a negative number. So take a carry 1. 1 is carried on a base of 100, so value will be 100. 100 minus 64, 36. 48, 1 carried, 47. And this is 88. 100 is 10 square. Last two places will have 2 digits. 37 is 2 digits, 47 is 2 digits. What will be the answer? 884736. 884736. One more problem. 992 whole cube. 992 whole cube. 992 whole cube can be written as 1000 minus 8 power 3. So this will be b plus 3x, 3x square, and next is x cube. 1000 minus 80, 1000 minus 24 is 976, 64 3s are 192, and this is minus 512. If I cube a positive number, will I get a negative number? No. So take a carry. If I take a carry of 1 on 1000, 1000 minus 512, answer is 488. From 192, 1 is taken carry. How much is remaining? 191. What is this value? 976. 1000 is 10 cube. 1000 is 10 cube. Last two places should have 3 digits. 488 is 3 digit. 191 is 3 digit. Answer is 976 191 488. Last one more problem before we close this topic. That is 92 whole cube. Fifth one, 92 whole cube. 92 whole cube. 92 can be written as 100 minus 8 power 3. So this will be b plus 3x. Next is 3x square. Next is x cube. 100 minus 24, 76. 64 3s are 192. Minus 8 cube is minus 512. If I cube a positive number, I will not get a negative number. Take a carry 1. 1 is carried on 100. 100 minus 512, it is still negative. So I cannot take a carry 1. I will take carry 2. 2 on 100, 200. 200 minus 512, still negative. So what I do is, I will take a carry 6. 6 on 100, 600. 600 minus 512, 88. 192, 6 is taken carry. 186. These 76. 100 is 10 square. Last two places will have 2 digits. 88. 186, what are the last 2 digits? 86. 1 carried. 76 plus 1, 77. So what will be the answer? 778688. So this is to find the cube of a number nearer to 10 power k. Let us discuss the type 3 in this module, how to find the cube root of a number, type 3. Please write down. My suggestion to you, keep practicing various problems based upon this concept. The more you practice, the more you become expert in this topic. Type 3. Type 3 is a very, very interesting type. Type 3. How to find the cube root of a number. This is the reverse of finding the cube of a number. How to find the cube root of a number. How to find the cube root of a number. Now, first we will discuss a concept. If I take the unit digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us cube it. 0's cube is 0. 1 cube is 1. 2 cube is 8. 3 cube is 27. 4 cube is 64. 5 cube is 125. 6 cube 216. 7 cube 343. 8 cube 512. 9 cube 729. These are the possible unit digits of a number after finding the cube of a number. Observe carefully. A perfect square never ends with 2, 3, 7 or 8. Identify 2, 3, 7 or 8 on the left hand side. Only these numbers on cubing I am getting a different unit digit. 0 cube is 0, 1 cube is 1, 4 cube is 4, 5 cube is 5, 6 cube is 6, 9 cube is 9. That means any number ending with 2, 3, 7 or 8 on cubing, I will get some other number ending with 8, 7, 3 or 2. In other words, it is nothing but the 10 minus unit digit of a number in the case of 2, 3, 7 or 8. 10 minus 2 is 8, 10 minus 3 is 7, 10 minus 7 is 3, 10 minus 8 is 2. Now let us take an example. 41 whole cube equivalent to 68921. I will try to find the cube root of a number. Cube the root of 68921. Step number 1. Start from the unit digit. Keep a slash after 3 digits. Why after 3 digits? Because I am finding the cube root. What is the unit digit of a number? 1. 1 cube is 1. So write down 1. 68. 68 lies between which two cubes? 4 cube 64, 5 cube 125. What is the lowest number? 4. Write down 4. 40. Next one. 15 whole cube equivalent to, we already found out in type 1, 15 whole cube is 3375. Find out the cube root. Cube root of 3375. Step number 1. Start from the unit digit. Keep a slash after 3 digits. These ending with which number? 5. 5. Which number on cube will give me 5? 5. 3 lies between which two cubes? 1 cube 1, 2 cube 8. What is the lowest number? 1. Answer is 1, 5. Another example. 32 whole cube is, already we found out these numbers, henceforth I am using that same numbers. 32 whole cube is 32678. So 32. Do the cube root of 32678. Start from unit digit, keep a slash. 8. 8 is because of which number? 2 cube. 32 is 3 cube 27. 4 cube 64. What is the smallest number? 3. Answer is 32. Please remember, all these numbers which I took in cube root, this concept is used only when the number is a perfect cube. Only when the number is a perfect cube, this logic is not used. If the number is not a perfect cube, we will use a binomial expansion 1 plus x power n. Before I close this topic, let me revise all the important topics. How to find the cube of a number? Type 1. We will find the cube of a number using a plus b whole cube. That is type 1. Type 2. How to find the cube of a number which are nearer to 10 power k? Learning from type number 2. If it is 10 power k, if k is 2, last two places should have 2 digits. If k is 3, last two places will have 3 digits. Type number 3. How to find the cube root of a perfect cube? So we did this one, we are doing the converse. Important learning from this concept. A perfect square never ends with 2, 3, 7 or 8. Only these 2, 3, 7 or 8 on cube, I will get a different unit digit. Remaining all the cases, it is the same. I hope you have understood these 3 varieties of finding the cube of a number. All the problems related to prime numbers. Please write down problems based on prime numbers. First we'll write some key points related to prime numbers. Then we'll execute all the key points related to prime numbers. Problems based on prime numbers. First point. A prime number has only 2 distinct factors. A prime number has only 2 distinct factors. That is 1 and itself. A prime number has only 2 distinct factors. That is 1 and itself. Next one. 2 is the only even prime. 2 is the only even prime. In all the prime numbers, the only even number is 2 is the only even prime number. Next. A prime number series is of the form 2, 3, 5, 7 and so on. Every prime number greater than 3, it is of the form 6k plus or minus 1. Every prime number greater than 3, it is of the form 6k plus or minus 1. In bracket, please make a note of it. Otherwise, most of the students will think that to check whether a number is a prime number, you have to just check 6k plus or minus 1 form, which is not always true. All the numbers which are of the form 6k plus or minus 1, all the numbers which are of the form 6k plus or minus 1 may or may not be prime. May or may not be prime. May or may not be prime. Every prime number greater than 3, it is of the form 6k plus or minus 1. Next one, every concept we will discuss in detail. 1 to 50, there are 15 prime numbers. 1 to 50, there are 15 prime numbers. From 51 to 100, there are 10 prime numbers. From 51 to 100, there are 10 prime numbers. A prime number has got only 2 distinct factors. One is not a prime number because it has got only one factor, that is 1. Problems. First problem is 3 power 11 plus 5 is 3 power 11 plus 5 prime or composite is 3 power 11 plus 5 prime or composite. Listen carefully here. 3 power 11 plus 5. 3 is an odd number. Odd number power any number. Odd. 5 is an odd number. Odd plus odd. What is odd plus odd? Even number. Is there any prime number other than 2 which is even? No. So what will be the answer? Composite. Answer is composite. 3 power 11 plus 5. 3 is an odd number. Odd power any number. Odd. 5 is odd. Odd plus odd is even. There is no even number other than 2 which is prime. Second question is 2 power 2007 plus 1 is 2 power 2007 plus 1 prime or composite is 2 power 2007 plus 1 prime or composite. Now see here, first note, can I say that a power n plus b power n is divisible by a plus b if n is odd? A power n plus b power n is divisible by a plus b if n is odd. Why? For example, a cube plus b cube is divisible by a plus b. By applying this concept, 2 power 2007 plus 1, 2 power 2007 plus 1 power 2007. 2007 is odd. So it is divisible by which number? 2 plus 1, 3. Any number divisible by 3, will it be a prime number? No. In prime number set, other than 3, there is no number which is divisible by 3 and a prime number. So what will be the answer? Composite. Proving a number, whether it is prime or composite, involves too many methods. Depending the merit of the question, you will use the logic. Third one. Third question. Is 973 prime or composite? Is 973 prime or composite? Is 973 prime or composite? 973 prime or composite? Again, listen to this concept. A power n minus b power n is divisible by a minus b for all natural numbers n can take. because a square minus b square is a minus b into a plus b. A cube minus b cube is a minus b into something. Applying this, 973 can be written as 10 cube minus 27. 10 cube minus 27 is 10 whole cube minus 3 whole cube. A cube minus b cube, it is divisible by 10 minus 3, 7. So if a number is divisible by 7, it becomes a composite number. It becomes a composite number. One more example is 27 followed by 5 zeros ending with 1 is 27 followed by 5 zeros ending with 1. Prime or composite? Prime or composite? Is 27 followed by 5 zeros ending with 1. Prime or composite? See here, this number can be written as 27 into 10 power 6 plus 1. Am I right? So 27 into 10 power 6 can be written as 3 into 10 square whole cube plus 1 whole cube. A cube plus b cube is always divisible by a plus b. 3 into 10 square plus 1 is divisible by 301, which is 7 into 43. Any number divisible by 7 and 43, it is a composite number. It is a composite number. So in all these problems, to check whether a number is a prime or composite, we are trying to decompose the number in the form of a power n plus or minus b power n. A power n plus or minus b power n. Next, one more question. This is a very interesting question. Next question. What is the value of d? What is the value of d? What is the value of d? What is the value of d such that? What is the value of d such that 197,000,190 is a prime number? What is the value of d such that 197,000,190 is a prime number? Options 3, second option 9, third option 5, fourth option 7, fifth option 1. This is a replica of a cat question. What is the value of d such that 197,000,190 is a prime number? Now, see here. What is the number given? 197,000,190. Suppose if I place a d value 5, this number will become 197,000,195. If a unit digit is 5, that means the number is divisible by 5.
Yes.
So this cannot be. Next one. If a number is divisible by 7, if a number is divisible by 7, you can write this number like this: 197 into 10 power 6 plus 196. This will be 196 into 10 power 6 plus 1. Number is divisible by 197. Another way to look at is, number is also divisible by 10 square whole cube plus 1 whole cube. A cube plus b cube is divisible by a plus b. That means by placing unit digit 7, this number is also a composite number. Are you all with me?
Yes.
By placing unit digit 5, this is also a 5. Now see here. Let us place 3. If I place 3, 197,000,193. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. 1 plus 9, 10, 17, 18, 27, 30. Sum of the digits is 30. If the sum of the digits is divisible by 30, that means the number is also divisible by 3. Are you all with me?
Yes.
Now, similarly, if I place 9, 197,000,000, 199, 10, 17, 18, 18 plus 8, sum of the digits 36. Sum of the digits is 36. That means number is divisible by 3 or 9. That means these also over. All these are over. What is the answer?
1.
Now you don't need to worry. 197000191 is a prime number, which I already checked. So classic problem which explains the divisibility rule of 5, which explains the divisibility rule of 3, which explains the divisibility rule of 9 also. What is the value of D? Such that this number is a prime number. How many, question, how many 4-digit, how many 4-digit palindromic prime numbers exist? How many 4-digit palindromic prime numbers exist? How many 4-digit palindromic prime numbers exist? How many 4-digit palindromic prime number? Now see here, there are some key points in this question. Number is a palindromic number. A number is said to be a palindromic number. If you read from left to right or right to left, it will be the same. And 4-digit, we have to check how many such numbers are prime numbers. Now see here, a 4-digit palindromic number will be of this form, ABBA. Now observe carefully, what is the sum of the odd places? A plus B. What is the sum of the even places? A plus B. Sum of the odd places, sum of the odd places equivalent to sum of the even places. If the sum of the odd places equivalent to sum of the even places, then the number is divisible by 11. If it is divisible by 11, will it be a prime number? No. Answer is, there exists no 4-digit palindromic prime numbers. Are you all with me? Now, this is not important. Please listen carefully. Note. First listen. Suppose if I take a 6-digit palindromic number, ABCCBA. What is the sum of the odd places? A plus B plus C. What is the sum of the even places? A plus B plus C. That means number is divisible by 11. Suppose if I take a 8-digit palindromic number, A plus B plus C plus D, A plus B plus C plus D. Number is divisible by 11. That means 4-digit palindromic number, answer is 0. 6-digit palindromic prime number, 0. 8-digit also. 8-digit also 0. N-digit palindromic prime numbers will be 0 where N is even. Where N is even. N-digit palindromic prime numbers. N-digit palindromic prime numbers. N-digit palindromic prime numbers will be 0 if N is even. This is the learning from this question. N-digit palindromic prime numbers is 0 if N is even. The concept which we use it to solve this question is sum of the odd places equivalent to sum of the even places. Then the number is divisible by 11. If a number is divisible by 11, other than 11, there is no number which is divisible by 11 and a prime number.
If n is odd?
N is odd, that also will. N is odd, it may or may not be. In that case, we will use a different notation. Just to give you an example, suppose if N is odd, a single digit written odd number of times. These are all divisible by 37. So depending upon the nature of the question, you will check whether it is divisible. Anyway, we will discuss right now 37 divisibility rule. There I will discuss your doubt once again. Next one. Next is a tricky question. How many 9-digit numbers? How many 9-digit numbers? How many 9-digit numbers that can be formed? How many 9-digit numbers that can be formed using the digits? How many 9-digit numbers that can be formed using the digits 1 to 9? How many 9-digit numbers that can be formed by using the digits 1, 2, 3 till 9? Repetition not allowed. Repetition not allowed. Are prime numbers. Are prime numbers. Very tricky question. How many 9-digit numbers that can be formed using the digits 1 to 9? Repetition not allowed. Are prime numbers. Repetition not allowed. Are prime numbers. Listen carefully. First we will read the question. How many 9-digit numbers? We require a 9-digit number. Digits are from 1 to 9. Second. Third point is repetition not allowed. Now see here. Suppose if 9 numbers are there. 9 numbers. This is the positioning of the numbers. 9 numbers. Repetition not allowed. So this number can be any number from 1 to 9. Yes or no? So there will be 9 digits that can come. 1 digit is already fixed here. 8 numbers can come. 1 digit here, 1 digit here. 7 numbers can come. One like that. It will go on up to 9 factorial. So in 9 factorial numbers, how many numbers are prime numbers? That is the question. Seems to be very difficult. See here. Out of this 9 factorial, there will be one number which will be like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes or no? What will be the sum of the digits? Sum of the digits is 1 plus 2 plus 3 plus 4 and so on. This will become summation 9. Summation 9 is 45. Sum of the digits is 45. That means the number is divisible by which number? 3 or 9. Suppose if I change the order. 1, 5, 8, 9, 7, 3, 4, 2, 6. What will be the sum of the digits still? 45. That means because the repetition is not allowed, only the position of the digits will change. So 1 plus 2 plus 3 is always 1 plus 3 plus 2. So in whatever way you write, sum will always remain 45. If sum is 45, that means all the numbers are divisible by which number? 3. So therefore what will be the answer? 0. Please write. So the important key points in this question is, we have to use all the digits 1 to 9. Repetition is not allowed. If a repetition is allowed, it may or may not be. That we will discuss it in fundamental principle of counting. So total the number of 9-digit numbers without repetition is 9 factorial. In that one I took one number. One number is 1, 2, 3, 4 till 9. The summation of the digits is summation 9, 45. 45 is divisible by 3. Irrespective of the change in position of the digits, sum will always remain 45. Next, another variety. I hope this is clear. Suppose, see here, from this one, how many 3-digit numbers, see here, important learnings, how many 3-digit numbers that can be formed by using the digits 1, 2, 3, repetition not allowed, are prime numbers, repetition not allowed means what will be one digit? 1, 2, 3. What will be the sum of the digits? 6. So answer is divisible by 3. Remaining digits will be like this. Right? Suppose how many 5-digit numbers? How many 5-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5. Repetition not allowed. Repetition not allowed are prime numbers. All these are subset of the questions whatever we discussed. Suppose again it will be, how many numbers will be? 1, 2, 3, 4, 5. What is the sum of the digits? 15. Again divisible by 3. I hope it is clear. Answer is, all these cases it is 0. Please write down. So once you know 9-digit number, then you can create your own questions with a 3-digit number, putting the digits where sum will become a multiple of 3. That's the idea. That's how the questions in CAT will be developed. You will take a tough question, you will divide that question into 10 easier questions, and from there the number of questions will be derived.